So in this video, I explain classification of constants. In the last video, I explained what is constraint. What is constraint? Here, the classification of constants. So in the constants, types of constants, first one is holonomic, non-holonomic, celeronomic, and rheonomous. We have four classification here. So first we are discussing about holonomic constants. What are the holonomic constants? See, R1, R2, R3 are position vectors, position coordinates of a system, of a particle, of a system. So if it is there, if we see the function in the function that depends on R1, R2, R3 dash dash Rn comma T equal to 0. See, if conditions of all the constants are expressed like this, the constants are said to be holonomic. The constants are said to be holonomic. See, these are the position coordinates of a system. If we express the constants with this equation like this, the function the function is r1, r2, r3 dash rn comma t with time that is equal to 0. If we equate to 0, those constants equation holonomic constants. If the conditions of the constraints like this equation that is equal to 0, you just observe that is equal to 0. If those conditions, that equation if we equate to 0, then those constraints in the category of holonomic constraints. See next, here t is time r1 r2 position coordinates. See, we take one example. The constants in the motion of a rigid body. Motion of a example 1. The constraints involved in the motion of rigid bodies. Motion of rigid bodies. See what is here. See, if the rigid body equation is like this: Ri minus Rj whole square minus Cij square equal to 0. So what is here the rigid body equation? If you take any rigid body like this is Ri, position vector of this one Rj. If we this one Cij. So what is there? This is a right angle triangle. Just Ri minus Rj whole square, that is equal to Cij square. This is rigid body equation. This equation we are equating to 0. Then the constant is called holonomic constant. If we equate to 0, the constant is called holonomic constant. What is this equation? The distance between these two particles, that is equal to Cij. The distance between these two particles are not changing, that is fixed, that is equal to 0. This is the distance between two particles of rigid body. So we are equating to 0, that we can conclude that is holonomic constant. If you take one more example, motion of a point mass of simple pendulum. This also I take an example before. This is here, this is a position vector, and A is position vector, R is R minus A whole square equal to L square. L is length of the pendulum, R is radius of the point mass. See here, R is the position vector of, see just this is R is the position vector of point mass. Then L the constant distance L, R minus A whole square equal to L square. See here also R minus A whole square equal to L square. We are equating to L square. Here also in this equation we have equal, here also we are equating to L square. So these two constraints undercome holonomic constraints. So this is about holonomic constraints. Here we are moving to non-holonomic constraints now. Holonomic, non-holonomic. What are non-holonomic constraints? Here the constraints are involved when a particle is restricted, see r square minus a square greater than or equal to 0. Here there is no equality term, equivalent greater than or equal. So greater than or equal. So it is not like equal. Here an holonomic constant equal to 0. Here greater than or equal to 0. So this type of equation, this type of equations of constraints will come under non-holonomic constraints. See here examples here for this one. A gas molecule in the container, in the any gas molecule in a container, that will come in non-holonomic constraints. That is second example. Motion of a particle on solid sphere, this will come under also non-holonomic constraint. Then next third example, an object rolling on rough surface. An object is rolling on rough surface. It is rough surface. An object is rolling without slipping. See, the condition is without slipping. An object is rolling on rough surface without slipping. The three examples are these three examples for constraints. Which type of constraints? Non-holonomic constraints. In these three cases, we have not equal to 0 or equal to sum. Here is not equal to 0, here greater than or equal or less than or equal, like that will be there. So this equal to 0 will come holonomic constraints. This is about non-holonomic constraints. These are the examples. So we are moving Celeranomus constant, third type of classification here. See, third one, Celeranomus. What is Celeranomus constraints? If the constants are independent of time, it is a function constant equation. If it is independent of time, for example f of x equal to 0, it is in the function, it is not depending on time, it is not there time term in the equation. So the function f of x in the terms of x only, it is not time, it is not depending on time. Without time, that is constraint equation goes to Celeranomus constraints. So that means the constraints are independent of time, independent of time. See, independent of time means it's not depend on time. Those type of constant equations or constraints goes to Celeranomus constraints. Next, fourth type, Rehonomous constraints. Rehonomous constant is opposite to Celeranomus. It is simple. If any constant equation or any constraint depends on time in the function, that is in the equation, that function depends on time also. If it depends on time, that goes to Rehonomous constant. It is opposite to Celeranomus. So these are the classification of constraints. So first one is holonomic, it is equal to 0. Then first one is equal to 0. Then second one, non-holonomic greater than or less than or equal to 0. This goes to second type. This first type. Third type, independent of time, it is not depending on time. Fourth type, it is depends on time. So these four types of constraints we have: holonomic, non-holonomic, celeronomous, reanonomous. In the reanonomous constraint, the constraint is depends on the time. It is depends on the time, it is independent of time. This is the classification of constraints. So I discussed simple topic, classification of constraints. Thank you.